I had chromosome 8, and within that chromosome, I picked Hypogonadotropic Hypogonadism 2 with or without anosmia, and that can be denoted as HH2. And in terms of clinical manifestation, we can have an absent or incomplete sexual maturation by the age of 18. And this is due to low circulating gonadotropins and testosterone levels within that individual. And then in terms of non-reproductive phenotypes, we can have a lot, but some of them include anosmia, which means you can't smell, cleft palate, hearing loss, and all of those present at a variable frequency. So some people may be able to smell a little bit or not at all, for example. And when we're saying anosmia, we often denote that as Kallman syndrome. And when we say that they're having a normal sense of smell, we can denote that as norsomic idiopathic hypogonadotropic hypogonadism. And this will be more so important when we get to prevalence. Here are some of the other symptoms. You can pause to actually read out each one if you would like, but for the sake of time, just know that the reproductive system, the sensory system, endocrine system, skeletal system, and central nervous system can all be affected here. Now, the age of onset can vary from infancy, adolescence, and adulthood. It's more common that you be diagnosed in adolescence when you can actually see the delayed onset of puberty. So it really just depends on when your symptoms present. And then for life expectancy, I couldn't find a specific range on any of the websites, but all of the symptoms listed are non-life threatening. So for that, we're going to say that the life expectancy is normal. In terms of inheritance pattern, we have incomplete penetrance, meaning that the way in which certain phenotypes are expressed can vary. So, for example, when we talk about our sense of smell, we can have a normal sense of smell and still have HH2. We can have a low or diminished sense of smell, or we can have a complete absence of sense of smell. In terms of polygenic inheritance, this HH2 is often seen in association with mutations in other genes. And then we also have locus heterogeneity, which describes mutations in different genes, whereby one mutation generates the same disorder. So generally, HH can be caused by other genes and mutations, so then it would just be denoted H8 and some other number. We also have variable expressivity, and we can see that when we look at our list of symptoms, they can vary. And I even read an example of a parent, the only thing that he had was a loss of hearing, and then everything about him appeared normal. And then they also talked about an oligogenic framework, which means that a limited number of genes contribute pathogenic alleles to the whole framework that's responsible for reproduction. So this leads to a decrease in reproductive fitness. We also have pleiotropy, as we have many phenotypic effects for that one gene. And then we have multifactorial, and this is in the sense that they hypothesize that in people who have a reversal of HH, meaning nothing particularly was done for them, a specific treatment, but their endocrine system started to function normally, they think that this happened because some undefined stimuli, and they think it may be environmental or due to sex steroid exposure, then led to normal activity. And then prevalence. One study found that 1 in 30,000 males was affected versus 1 in 125,000 females. Another found that for every 4 males, 1 female was infected, so males are more likely to be affected by HH. And then in terms of KS, which we talked about earlier, 2/3 of individuals presented with HH. And of the patients that present with HH, 10% of those people have mutations in FGFR1, which is the specific gene I'm talking about. And then diagnosis can typically be done by a pediatric endocrinologist upon clinical examination, and then you do biological testing that will show that they have low testosterone, estradiol, etc. Or we could do it from the molecular genetics approach, which we would be looking at deletion and duplication analysis, targeted variant analysis, and sequence of the entire coding region. And to be a little bit more specific, we would be doing FGFR1 and looking for the denotion of just Kallman syndrome type 2 in and of itself. And then finally, in terms of gene expression, we see here that On to gene expression. You can see that it has an effect in the brain, which is on our big chart of symptoms, the eyes, the endocrine system, which we talked about specifically, as well as the female and male tissues. And then we can also see some that we might find a little bit unexpected, like the liver and gallbladder, as well as the digestive tract. Feel free to pause here and look at all of the different things that can be expressed in, but that's the end of my presentation.